Hello everyone, I'm Rifa and I'm going to present our project Handwritten Digit Recognition for Attendance Assistance done by our team under the guidance of Professor Jamuna S. Murthy, Assistant Professor, Department of CSE, Ramaya Institute of Technology. So, handwritten digit recognition is the process of converting images of handwritten digits into a digital format. This would also save a lot of time and money. So, the heart of our project lies within the ability to develop an efficient algorithm that can recognize the handwritten digits which are scanned and sent as input by the user. We are going to demonstrate this model through attendance assistance. This does not only have professional and commercial applications, but it can also be used in our day to day life and it can also be of great help to the visually impaired. HDR is the ability of the machine to recognize human handwritten digits. It's a hard task for the machine because the digits are not perfect. Our model tries to solve this problem. So the objective of our project is to recognize roll numbers from pictures, which would help us to take attendance easily. This would save time from marking absent every single time to marking absent all at once. So for this project, we use convolutional neural network, which is a type of deep learning algorithm that takes the image as an input and learns the various features of the image. So the convolutional layer contains a set of filters or parameters which help us to learn the features of the image. And for this, we also use a kernel, which is a small matrix of height and width smaller than that of the image, which is need to be scanned. We use polling layer, which is used to reduce the dimensions of the feature map. We also use the FC layer or the fully connected layer, which consists of the weight and the biases along the neurons and is used to connect the neurons between different layers. We also use MNSIT database, which is a large database which has a lot of handwritten digits and many other such data. Over here, we use the handwritten digits for our project to train our model and to test it. So, what we exactly do in this project is that we import the libraries and load the dataset from MNSIT. We pre-process the data, create the model, we train this model, and then we evaluate the model based on our test results. And then we also create a graphic user interface to depict or rather predict the digits. Let us try to understand this with the help of picture. So the computer takes this image, which is on the left, and understands it as a connect or a combination of matrices. It then allots a number for each of these matrices from 0 to 225, which depicts the brightness. 0 is complete dark and 225 is complete bright. Each of these matrices has a particular number assigned to it, and with this information, it performs the further operations. So first we import the libraries which we will be requiring. We then import the data from MNIST and divide the data of handwritten digits into two parts, the training data and the testing data. The training data has 60,000 data sets. We then see that the image that has been imported is either binary or black colored. Over here we see that the image is colored, so we need to convert it into binary in this form for further operations. So here we get the value of each pixel. We see that the value of the pixel should lie between 0 to 225 for binary. We then normalize it or get it in between 0 and 1. We then reshape and change the dimensions of each image, which will be required for the operation of the kernel. Then we create a deep learning model which has a few convolutional layers and a few FC layers. We then use the training data to train our model and then use the testing data to test if the model is depicting the right value and has a high accuracy rate. Here we see that the predictions of the model is same as the number which is being depicted in the pictures. 7. High efficiency. Now we import certain libraries and use our data set or the number which is being given by us using paint to check if the model is predicting accurately. We make certain changes in the image so that we get the right output. Here we see that the number being depicted is the same as the one being predicted. Therefore, our model is pretty accurate. Thank you so much for watching.